Today we are going to talk about block storage options offered by Amazon, and this service is called as Elastic Block Store or EBS. It is quite often referred to, and it makes it quite an interesting option because of the features offered by Amazon. So, quite as usual, that's my name, and you know who I am. So let's move forward. So when you're talking about the storage choices, all these multiple choices are available starting from durable object storage and archival storage, block storage, and file level storage. So today's focus in depth is going to be focused on Amazon EBS, that is the block storage for EC2. So why should I choose this? What makes this an interesting choice when compared to other things is this has a performance mechanism optimized at base level. What it means is you can change the performance of your EBS storage anytime you want. It is not just the performance options, all the redundancy options. We will see some of those things, why EBS makes a better choice when compared to all other third-party storages in a short while. So when you are talking about the EBS, you can think of it as analogous to an existing external hard disk that you attach into your server. But except for the form factor or how it looks like, we never see it, but it is not the same. It is definitely not the same because it has a persistent block storage. For example, if you detach the EBS volume which is attached to a server, then you can reattach it to some other server almost with a few clicks. When you put it in one particular availability zone, it stays there in that availability zone, but you can reattach and attach to any other server any number of times. So this mounting operation and unmounting operation or attaching or detaching operation can be done any number of times without any impact to the disk itself. So it's all a software you are dealing with a software defined storage here, and it is a persistent at a block level and low latency performance. What it means is the IO speed that you get with this disks is amazing, and it's not just amazing in terms of words, but you can increase or decrease it by changing the values on your dashboard. Say, for example, today you need 1000 IOPS, that is input output operations per second, and after 10 days your business grows like anything and you want 20,000 IOPS. So all you have to do is go ahead and change the performance for this disk and let it optimize for 5-10 minutes. And after that, you will be able to achieve the 20,000 IOPS performance at that point onwards. So let us say for some reason your business has settled down to a more 15,000 peak volume and not 20,000. So you can downgrade your performance also. Of course, there's a cost associated with this scaling of performance. So you pay the higher cost when you go to 20,000, and when you come down to 15,000, you will pay a little lower cost. So that is what it means as a low latency, consistent performance. If you dial it, as the Amazon calls it, you can dial your performance just like a radio knob. You're increasing your performance from 0 to 100 to 100 to 10,000. And consistent means if you set it at 20,000, you are guaranteed to get the 20,000 IOPS performance. It is not like any other storage where you will get an approximate of that value or 80% of the peak value throughput that you can achieve. Here you more or less get the throughput that you are expected to achieve there, either in a throughput terms or you are expected to get the same amount of IO performance there. And remember that every EBS volume that you are getting created is automatically replicated within the same availability zone. If you remember, Mumbai has two availability zones, A and B. And if you create an EBS in availability zone A, Amazon will automatically create one more replicated copy in A itself. You will not have access to it. You will not be able to modify it, read it. But if any reason your primary volume is corrupted or not accessible, automatically your traffic will be routed to your replicated volume. In other words, the fault tolerance is built into the volume itself. You don't have to worry about having two disks creating RAID volumes and mirroring them, or doing striping and all those things. You don't have to worry about the disk failures in this case because it is automatically replicated at the availability zone level. And remember the other thing, it is availability zone specific. If you create it in A, it will not appear in B. When I say A, it is availability zone A, and it will not appear in B. The only way to you can move them from one availability zone to another availability zone is you take a snapshot and move that snapshot into a different zone. So these are the different concepts, or these are the different benefits that Amazon EBS volume offers to you, which does not happen when you use a conventional external hard disk. So it might feel, it might look like one, but it is not the same because of the performance optimization that you can do with through the console. Either you dial up the performance or the consistent performance that it offers and the replication properties it offers. So keep that in mind when we're talking about EBS. So this is what I was talking about. Let us say there is a server here, the left hand side. Let me just mark it here. So when I say Amazon EC2, it is nothing but a server or a VM in the cloud, and here also another VM. So let us say this is the first VM that was running in the cloud, and this EBS volume that is shown at the top is mounted to the server 1. And after some time, for some reason, this server has gone offline or something has happened, and you want to dispose that instance. All you have to do is unmount it. That is why it is shown as a dotted line, and remount it in the other instance. All the storage will be available on the new instance. So this concept might be familiar with many storage admins, but people who are unfamiliar with how this data gets moved or transferred, this is how it happens in AWS as well as in some SAM mounted storages. So the data is persistent and independent of the EC2 instance. In other words, the data is not dependent on the server to which it is connected to. So you get the persistence of data. Even if the server goes offline, you can still connect it to another instance and access the data. It is one key difference that you always need to remember. EBS volume, whether it is connected to the server or not, your data will be available. So moving forward to look at it in a more pictorial way of how all these things happen. So what is an EBS volume? What is it exactly? So here I have just shown an AWS region. Inside it, you have two availability zones, and I have created a simple EBS volume. Let us assume it for that moment. So the next thing what I'm going to do is Amazon is automatically creating a replica. It is not me. That is why it is shown in a different color. Amazon creates that replica. So this way you get an redundancy of your storage or durability of your storage automatically. If for some reason this EBS volume goes offline, the blue color copy will become the primary copy. So this translates into a 5 nines of service availability. That is what it means. So out of let us say 999,000 times you are trying to access your disk, there will be only one failure, and that is very, very less compared to on-premise disk storage offered by most vendors. Apart from that, Amazon has calculated it as the failure rates for their disks is ranging from 0.1 percentage to 0.2 percentage. And remember, Amazon keeps on improving their own internal performance all the time. This information was taken from about 6 months old. They might have improved it even more, but it is. I can say one thing: it is definitely not lesser than this. When I say annual failure rate, in an annually calculated total number of disks that Amazon supports, only 0.1 percentage of their disks are failing. So that is what AFR means. So let us look at what are the different types of disks that are available, what are the different performances that you can achieve, and what are snapshots. These are some of the additional components that makes Elastic Block Store one of the favored storage in the cloud. So when we talk about the performance, it is measured in two ways. Predominantly, it is measured by IOPS, that is the number of read and write operations per second. So typically, some companies use it at a 64 KB per read and write, or some companies will measure input as one size and output as another size. So but in the EBS volumes, it is consistent, and you can go ahead and look it up wherever you want. Next thing is latency. That is a time between the submission of the write and then the completion of that write, or the time between submission of the read and how much time it completes to the read. So think of latency in simple terms is you look for a website www.google.com, you type it in your browser, press enter, and how much time you wait for the browser to render the page. So that is what is a latency is, because obviously the request is going to the DNS server, from the DNS server to the actual web server, reads the content from the database or some data store, and pushes the content all the way back to your browser. So how much time this whole operation takes is the latency of your network level. But if we are talking about a network latency at an IO level, that is a disk level. So how much time the disk itself takes for IO. So this latency is at a disk level. That is what you should remember. Usually when people talk about latency, they will be talking about latency at a network level. So another measurement for disks is throughput. That is how fast I can read and write into my disk. That is the total IOPS into the IO size. So that is what my throughput means. So these are the different parameters. The performance is measured when we are talking about block storage. So let us see which one you should choose. What is more important to your workload? That is the one important question that you need to ask your clients. Is your application more dependent on IOPS, or is your application more dependent on throughput? To put it in an example, mobile applications are more dependent on IOPS because the amount of data that transacts is less than 1 KB most of the time. So you are going to read and write a lot of requests. You are going to make a lot of requests from millions of devices, but very, very small requests. So IOPS makes a lot of sense there. But when you're looking at a movie streaming content or a video streaming content, throughput is maximum because we are looking at a 4K definition file, and think of some 10,000 users are trying to stream a 4K movie. So you want to look at how much throughput I can achieve or how much bandwidth I can achieve. So depending upon your application, you need to go for IOPS optimized disk or a throughput optimized disk. Amazon has variants for both of these. So if you say IOPS, you need to think of a particular disk in mind. I'll show you a flowchart which helps you to make the decision very easily. So some of the best practices I'm going to show here in between. So the block size determines whether your application is IOPS or bound or throughput bound. So how do I know this block size? Typically what you do is you go and talk to your application developer and ask them how much data they are going to write to the database, or how much data they are going to read from the database, or any storage at any given point of time. So they will know that I'm going to query this much data, and the database will be responding me with all this data, and it will come to totally about 1 MB of data or 1 KB of data. So based on that, now you know your IO block size, and from there you can go to IOPS or throughput. So that is how you identify which is constraining your application. So this is some of the maximums that was achieved by Amazon some time back. When we are talking about IOPS, you can achieve a 20,000 IOPS at the maximum level as on today. So that is the maximum performance Amazon EBS volumes gives you. And when you're talking about the throughput, you can achieve a maximum throughput of 320 megabytes per second. And remember, this is a per disk limit. If I say about 2 disks, so I can have a total throughput of about 40,000 IOPS because each disk allows me to have 20,000 IOPS, and in total I can have a 40,000 IOPS of performance. Likewise, if I want more throughput, then I will have about 640. So I need to do some configuration so the data is replicated so I can read and write from both the disks at the same time. So you will probably have to do some engineering at the disk level, but this is the maximum that you can achieve in a single volume in Elastic Block Store. And remember, each block store can scale up to 4 terabytes if I'm not wrong. As I always saying, don't try to remember these numbers because you can go to Amazon documentation anytime and you can refer them. But remember, there is an upper limit for IOPS and also for an upper limit for throughputs as well. So here is a simple calculation of how you can achieve your 8,000 IOPS as it is shown here, or the block level. The 8 KB, the multiples that you see here is the block level. This is here I'm writing 8 KB blocks, and if I'm doing 8 KB blocks in 8,000, the maximum that I can achieve is 64 Mbps only. But if I'm going to split it into two, or if I'm going to have a 32 KB block, Amazon has optimized it for this number, and if you achieve it for 32 KB, then you will have a maximum of 256. So people who are not familiar with the block level, you don't have to really memorize it. As I said, you go and talk to your application team and find out what is the block size that you are going to write from your application, whether it is 8 KB or 16 KB or 32 KB, whatever the number is. Then you multiply by the provisioned IOPS that you set in your EBS volume. So a multiplication of this will give you the bandwidth that you can achieve in that disks. So a little bit of mathematics is involved when you're trying to optimize the disk, but most of the default cases, the default configuration does very well. This is all performance optimization tips and techniques. And if you find that your application is slowing down, then you will see what is my IOPS that I configured for my server and what is the block size. Then you start working out in the reverse direction. So how do I choose which disk is right for me, whether IOPS based or throughput based? Amazon offers two broad based categories. At the top level, you have this SSD based disks, that is solid state disks, one of the fastest that you can get on the market. Another one is the typical magnetic spinning disk or spindle based disks. So it is little cheaper, but the throughput that you can achieve with the spindle disks are really good, and the longevity that you can get is also very high. So under SSD, you get this I01, IO1, not I0, IO1, and GP2. These are all, don't ask me why they are named as I01 or IO1. That's how Amazon has named it. We just have to follow it. There is a logic behind each of those disks, why it is called as so, but that is not really necessary for us to understand to that level. So when I say IO, it is very high IO intensive applications or a consistent database performance, all those things you will use an IO disk. When you want a GP2, it is a more baseline performance, more predictable. I am not worried about my peak performance. I just want a predictable baseline. And whenever there is a burst capacity, say for example, suddenly there is more users coming in for 5 or 10 minutes and then it stabilizes after some time, then GP2 is my best option. Whereas when I don't know whether I'm going to, I mean, when I know that I'm not going to burst, I'm going to have a very consistent performance. Like throughout the day, whatever application I'm doing, this is going to be my read and write, like a big data analytics or a Hadoop based processing systems. They will have a very consistent read write performance throughout the lifetime of the cluster. So in those cases, your ST1 or HDD based, that is hard disk drive based disk is ideal. And then there is a cold storage is also possible. So the SC1 is a cold storage where you are not worried about IO performance, but you want the most cheapest block level storage that is available to you, and where you are going to do very slow processing of the data. You are not worried about your performance so much, and even if it slows down a little bit, also you are not worried. So colder log processing and some analytics, warehousing processing, and all those things, SC1 makes the ideal choice. Once again, all these things will need discussions with your business analyst team or with your application team to understand the ideal disk. If you're not sure, go with the GP2. You will not be more, I go one if you will not be most probably wrong. And then you can work on optimizing it later also. So here are I'm going to break up some numbers here. I'm going to just quickly run through them because as I always say, the numbers are not necessary. You have to work with your client and then understand which number is the best number for you. So the important thing is here, as I shown, the capacity of the disk goes from 4 gigabytes to about 16 terabytes. So that is the maximum volume size that you can achieve with an ST1. It is a throughput optimized disk, ideal for block storage and high throughput sequential workloads. In other words, think of it as video streaming or Hadoop cluster or those kind of systems. So that is where an ST1 comes in. So when we move forward, we are talking about I01, that is a solid state disk. Here, IO performance is more important when we are talking about an SSD disks. And in this case, the max ratio is 50:1. So that means that you can scale up to 1:50. So 50 times more performance that you can achieve. And ideally, it is suited for critical applications and database with a very high IO. Think of Flipkart or an Amazon during shopping festival. In that case, the database will have a lot of requests and all happening at a very fast pace, and all of them needs to have IO performance which is consistent with customer needs. Think of you're at the payment gateway and there is a delay in the payments. You will most probably you will be frustrated with that experience and not come to the same website. So sustained IO performance is one of the critical criteria for those kind of databases, and I01 ideally delivers that for you. So if I move forward, this is a flowchart that I spoke about. How would I choose which disk I need? So how do I look at it is in the top you have your IOPS and throughput, and once you do your talk to your application team and find out what is the block size and calculate the IOPS that you need, and if you will get either one of these numbers. And it's very simple, it's straightforward from that. If you need more than 65,000 IOPS, you go to an I2 based disk. And if it is less than 65,000, what is your latency requirement? How much time I can wait for the data? So if you think that I cannot wait I need to have a lesser than 1 millisecond latency, then I will choose an I2 based disk. So if I can wait for 1 millisecond, 2 milliseconds, or something around that, then I am going to ask you the question of what is the IOPS per volume you need. Remember, this is at a total application level, and this is at a per disk level. So if my disk, each disk can have an IOPS of less than 10,000 K, I will go for this one. And once again, if I need more than 20,000, I end up being at I01 itself. So there is another disk. Likewise, you navigate the chart on the right hand side also. What is my smallest throughput, whether it is a random or sequential? When I say random, think of you are playing a movie and you suddenly don't like the first 10 scenes and you want to move to the half an hour forward into the movie. So you're randomly seeking some data there. And whereas the large sequential read is you're watching the movie sequentially, one scene after another scene. So that is what a random small IO means. Sometimes people will seek and then do random IO operations. And if this is going to be more, then you will need an solid state disk. But if it is always going to be a sequential data, then you continue with the throughput optimized disk and follow it all the way down to the necessary volumes that you have here. So not something to memorize, but this is how you logically approach the problem of whether throughput optimized disk is good for me or IO optimized disk is good for me. And remember that you can change your size of your volume. You can change the type of disks also. In this case, I'm just showing you a symbolic way of increasing your disk size. Let us say at the bottom you have a 5 GB disk and you want to increase it to 50 GB. You can go to your console and change your size anytime. And in this case, I'm staying in the same group where GP2 becomes a bigger GP2, I01 becomes a bigger I01, and it goes on likewise. So this is absolutely possible, but there is a caveat here. You cannot do this. You cannot come down here. The reason for that is once you go up here, Amazon assumes that you have put more data. Let us say you've gone from 5 GB to 50 GB and you stored about 40 GB of data there. And when you try to dynamically resize it, Amazon doesn't know where your data is residing, and there's a possible of a data loss or corruption is possible. So dynamically they don't allow you to resize your data, resize your disk to a smaller number. So the only way to do that is you take a snapshot which will copy only the amount of data that is in your disk and put it into another volume of smaller size. So that is only way you can resize it. So if anybody asks you how do I resize, the only simplest answer is I will take a snapshot and create a volume from my snapshot. So let us move forward. What other disk level operations is possible? Whether I can decrease my volume, we just now spoke about it. No, that is not possible. I need to take a snapshot of it. So changing volume types, if you carefully notice here, I'm changing from one volume type to another volume type from GP2 to I01. That is also possible. From here, in this case, I can go from I02 to I01. If you're wondering why would I want to do that, say for example, you are thinking that your application is throughput optimized, but after starting to fine tune it and working with disk level experts, you understand that it is no longer throughput optimized, but it is IO optimized. So in those cases, you might find a need from switching from one type of volume to another type of volume. As you can see here, the image, this is an SSD disk, and this is a solid state. This is a solid state disk, and this is one is a magnetic spinning disk. So you might want to shift from one volume to another volume. It is not always all combinations are possible. There are certain combinations that are possible. Depending upon what is your source, then you can choose your appropriate disk combination where you can move to. So, but remember that changing volume types is possible with some limitations. So there is another performance IOPS increase. So as the image that shows here, you can increase your IO performance also, as from 10,000 IOPS to 20,000 IOPS, and from 20,000 you can come back to 5,000 or 6,000 also. That is also possible. Increase as well as decrease, both are possible in terms of IOPS cases. So that is another disk level operations allowed. And finally, you can combine different modifications. We just now spoke about it. This is the tricky part. Don't try to memorize it or by heart it. You just remember that different disk level combinations are possible, but not all the combinations are available here. So this GP2 becomes a bigger size IO1. It's a combination of different things. It is not just type change, size change is also there, performance change is also there. That is what I'm trying to show here in this slide. And finally, some use cases. So as you can see here, if you have a hot data which is used for 0 to 7 days, then you use the GP2. I'm just giving you different use cases which you might come across in your real life scenarios. If your customer says that I have data which is actively accessed every single day, just go ahead and recommend them a GP2. And if you say that I need a warm data, warm standby, then you tell them that ST1 is good for you. So that is how you choose here. There's another use case at the bottom. Like think of an SQL Server database that you have, and in the single SQL Server itself, you will have different type of storage requirements. One for a backup, one for transaction logs, and also for partial backups. So I can configure these kind of different storage ST1 itself. Or if I think that the full backup is not going to be accessed every single day, I can even configure a cold data storage for that backup. So instead of ST1, I can go for an SC1 also. And on the right hand side, as it is shown, the actual data files can be in GP2 also to improve the performance. As you can see, there is an SSD based disk. So the actual data here, I'm just talking about this one, the actual data will be more faster for read and write operations. And whereas the commit logs will be in ST1, that is a spinning disk. So that is the background conceptual part of EBS volumes. Thanks for listening patiently.